It may release some other objects that reach the planets, and it will continue along its course.
It's interstellar. It came from outside the solar system. Could it be a Voyager-like meteor?
The data streamed back from the James Webb Space Telescope, and a chill went through the astronomy community. The target was 3I/ATLAS, an interstellar comet just passing through our cosmic neighborhood. But the information was wrong. It was all wrong. The chemical signature was unlike anything seen before, and its behavior was erratic, to put it mildly. This object, which traveled for possibly billions of years across the void, is now approaching our sun, and it's starting to change. What many overlooked were the initial warning signs that this was no ordinary comet, and now the truth is coming out, and it is far worse than anyone dared to imagine. The object that shouldn't exist. The James Webb Space Telescope, humanity's most powerful eye in the sky, was designed to see back to the dawn of time, to witness the birth of galaxies. But recently, it was pointed at a much closer target, a visitor passing through our own cosmic backyard, and what it saw has sent shockwaves through the scientific world. The object is named 3I/ATLAS, an interstellar comet, only the third such traveler from another star system ever detected. Scientists were ecstatic. They expected to find a pristine snowball of ice and dust, a time capsule that could tell them about the birth of planets around other stars. What they found instead was, to put it mildly, a complete and utter shock. The data was not just surprising, it was profoundly wrong, shattering long-held theories and raising terrifying new questions. You see, many people are crazy about the idea of finding pristine comets. They are supposed to be simple. The thing nobody tells you is that a comet's composition is like a fingerprint, telling you exactly where it came from. Our own solar system's comets are mostly water ice, like giant, dirty snowballs. But 3I/ATLAS is different. The Webb telescope's sensitive instruments detected its chemical makeup, and it was loaded, absolutely packed, with carbon dioxide. The ratio of carbon dioxide to water was one of the highest ever recorded in a comet, a finding so strange it sent researchers scrambling to recheck their models. It was like finding a polar bear in the Sahara Desert. It simply shouldn't be there. This suggests the comet formed in a part of its home star system that was incredibly cold, far colder than where our own comets were born. Or it could mean something else, something far stranger. What many overlooked in the initial excitement was the comet's behavior. Even before Webb got a look, astronomers noticed it was active much earlier than expected. Comets typically start to form their fuzzy halo, or coma, when they get close enough to the sun for water ice to turn directly into gas. This usually happens around the orbit of Jupiter, but 3I/ATLAS was already fizzing and outgassing when it was much farther out, at a distance where sunlight is far too weak to boil water. This early activity implies that it's not water that's driving its transformation, but other, more volatile ices, like the carbon dioxide Webb confirmed. It's as if the comet has a much lower boiling point than anything we're used to, making it incredibly unstable. This visitor isn't just passing through, it's actively changing as it gets closer, and its bizarre chemistry is the engine of that change. It's a ticking time bomb of cosmic proportions. This 1-2 punch of a bizarre composition and even stranger behavior has left scientists stunned. It's not just an oddball, it's an impossibility by our current standards. Every new piece of data only deepens the mystery. The object is estimated to be a behemoth, perhaps up to 7 miles wide, making it potentially the largest interstellar object we've ever seen. And it's moving at a blistering speed of over 130,000 miles per hour, faster than any comet from our own system. It's bigger, faster, and weirder than anything we've ever encountered. The initial hope of studying a simple alien snowball has been replaced by a chilling realization. We have no idea what this thing is or where it truly came from. The promise of answers has been replaced by a flood of confounding questions. The comet's strange makeup was just the beginning of the nightmare, a relic of the dawn. Before the James Webb Space Telescope revealed the comet's impossible chemistry, the story of 3I/ATLAS was already one for the ages. It was first spotted on July 1, 2025, by the Atlas Survey Telescope in Chile, a system designed to be our last alert for asteroids on a collision course with Earth. Almost immediately, astronomers knew this was no ordinary object. Its trajectory was all wrong. Instead of a gentle elliptical orbit around our sun, like the planets and asteroids we know, this object was on a hyperbolic path. That's a fancy way of saying it was moving too fast to be captured by the sun's gravity. It was a cosmic tourist here for a brief visit before heading back out into the infinite darkness of interstellar space. The implications were staggering. This was only the third time in history humanity had ever confirmed a visitor from another star system. The first was the bizarre cigar-shaped object named Oumuamua, and the second was the more comet-like 2I/Borisov. Each was a precious opportunity to study material that had formed around a completely different star. But 3I/ATLAS was special. You see, the thing nobody tells you is that the direction an interstellar object comes from is a huge clue to its origins. Oumuamua and Borisov came at us head-on relative to our sun's own journey through the Milky Way. But 3I/ATLAS is coming at us from the side, a trajectory that suggests it originates from a completely different and much older part of our galaxy. Many people are crazy about finding old things, but this object redefines the word ancient. By tracing its path backward through space, computer models made a shocking prediction. There's a high probability that 3I/ATLAS originated from what's known as the Milky Way's thick disk. This is a region of stars located above and below the main galactic plane where our sun resides. The stars in the thick disk are ancient, believed to be billions of years older than our own solar system. If this comet came from one of those stars, it could be 7 billion years old, or even older. To put that in perspective, our own solar system is only about 4.6 billion years old. This means 3I/ATLAS could be a wandering relic from a time before the Earth, the Sun, and all the planets even existed. It's not just an interstellar visitor, it's a primordial ghost. What many overlooked in these mind-bending calculations is what a journey of billions of years through interstellar space would do to an object. For eons, it would have been bombarded by cosmic rays, high-energy particles that zip through the void. This constant radiation bath could have fundamentally altered its surface, cooking it and creating a shell of exotic ices, which might explain the bizarre carbon dioxide signature that Webb later detected. It has been drifting through the near absolute zero cold for longer than our planet has been alive. This object isn't just a piece of another solar system, it's a witness to a huge swath of galactic history. It has seen stars born and stars perish. It carries the dust and radiation of its unimaginable voyage. This isn't just a scientific curiosity, it's the oldest macroscopic thing we have ever had the chance to study up close. The nitrogen iceberg. The revelation that 3I/ATLAS is an ancient ghost from a long-dead star system was mind-bending enough. But as scientists dug deeper into the baffling data, they realized that its age was just one piece of an increasingly bizarre puzzle. The numbers from the James Webb Space Telescope simply didn't fit any known model of a comet. The sheer weirdness of its composition and behavior forced researchers to think outside the box, to come up with new, radical theories that sound like they were ripped straight from the pages of a science fiction novel. These aren't just minor adjustments to old ideas. These are complete reimaginings of what an object like this could be. And each theory is more shocking than the last. One of the leading new ideas is what some are calling the nitrogen iceberg theory. You see, but not all things are what they seem in space. We think of comets as dirty snowballs made of water ice. But what if this one is made of something completely different? This theory suggests that 3I/ATLAS isn't a comet in the traditional sense at all. Instead, it might be a massive chunk of pure frozen nitrogen. The thing is, for a piece of nitrogen ice this big to form and survive, it would have to be chipped off the surface of a planet similar to Pluto in another solar system, an exopluto. Imagine a distant frozen world with mountains and plains made of nitrogen ice. A massive impact from an asteroid could have blasted a chunk of this nitrogen crust into space, sending it on its billion-year journey to our solar system. This would explain so much of the weirdness. Nitrogen ice boils at a much lower temperature than water ice, around -320 degrees Fahrenheit. This means it would start turning into gas far away from the sun, which perfectly explains why 3I/ATLAS became active so early in its approach. It would also explain the strange readings from Webb. But here's where it gets really crazy. If it is a nitrogen iceberg, it would mean we are looking at a literal piece of the surface of a planet from another star. It's not just a random snowball, it's a piece of alien geography, a fragment of a lost world. The thought that a chunk of a planet from another star is currently flying past Earth is a massive wow factor that has astronomers buzzing with excitement. Another, even more dramatic theory is the cosmic shrapnel hypothesis. Many people are crazy about the idea of cosmic collisions, but the thing nobody tells you is what kind of debris they can create. This theory proposes that 3I/ATLAS isn't a pristine object that formed gently with its star system. Instead, it's a piece of galactic wreckage, a survivor of an unbelievably violent cataclysm that happened eons ago. Picture this: a giant planet, maybe the size of Jupiter or even larger, wanders too close to its star. The star's immense gravity would have torn it to shreds in a cosmic tug-of-war, an event known as a tidal disruption. The planet would have been ripped apart, and its core and mantle sent flying out into interstellar space. If this theory is true, then 3I/ATLAS isn't a comet at all. It's a planetary fragment. It's a piece of the deep interior of an alien world. This would explain its enormous size and its strange, dense composition. It wouldn't be a light, fluffy snowball, but a dense chunk of rock and exotic ices that were once under immense pressure deep inside a planet. Every observation we make wouldn't be of a comet's surface, but a cross-section of a destroyed world. It would mean that as it flies by, it's giving us a glimpse into the autopsy of a planet that perished billions of years ago. It's a haunting idea that this silent visitor is actually a tombstone, a memorial to a long-lost world that was violently erased from existence. Perhaps the most mysterious theory is that of the dark comet. What many overlooked is the effect of deep space itself. Imagine a normal comet full of water and other ices. Now, let it drift between the stars for 1 billion years. Over that immense timescale, it's constantly being bombarded by cosmic rays. This intense radiation, according to the theory, would cook the surface of the comet, breaking down simple organic molecules and reforming them into a thick, dark, tar-like crust. This shell would act like an insulator, trapping the more volatile ices like carbon dioxide and nitrogen deep inside. So 3I/ATLAS would have flown through the galaxy looking like a dead dark rock, completely inactive. But as it entered our solar system and began to warm up, the pressure inside would have started to build. The trapped gases would expand, pushing against that dark, brittle shell. Eventually, the crust would crack. But instead of a gentle, continuous fizz like a normal comet, a dark comet would erupt in violent, unpredictable jets of gas and dust as the high-pressure material bursts through the cracks. This would perfectly explain the object's sudden and early activity and why it seems to be behaving so erratically. We aren't seeing a comet wake up. We're seeing a pressure vessel break apart. It's a ghost in the machine, an object with a hidden, violent interior that is only now being revealed. But its ancient origins couldn't explain its most disturbing secret of all: debunking the messenger. Just when the story of 3I/ATLAS couldn't get any stranger, a controversial and tantalizing theory was thrown into the mix, one that takes this cosmic mystery from the realm of astronomy into something else entirely. The idea was championed by Avi Loeb, a Harvard astrophysicist who is no stranger to shaking up the scientific community. He was the one who famously suggested that our first interstellar visitor, Oumuamua, might have been an alien technology, not a natural object. And now, looking at 3I/ATLAS, he's suggesting we should consider the same mind-bending possibility. To put it mildly, this has ignited a fierce debate, pitting mainstream science against the explosive idea that we are not alone. You see, Loeb's argument isn't just based on a hunch, it's rooted in the object's bizarre characteristics that defy easy explanation. The thing nobody tells you is that 3I/ATLAS's trajectory is suspiciously convenient. It's not just a random flyby. Its path brings it for unusually close passes of not one, not two, but 3 planets in our solar system: Jupiter, Mars, and Venus. On top of that, its trajectory is almost perfectly aligned with the ecliptic plane, the flat disk where all the planets orbit the Sun. The probability of an interstellar object arriving with such a perfect alignment and timing for planetary flybys is incredibly small, on the order of 0.0005%. Loeb argues that we must ask the question, is this a coincidence or is it by design? What many overlooked in the early days was the lack of a prominent tail. For an object so large and so active, especially with its high carbon dioxide content, many expected a brilliant, classic cometary tail of gas and dust. Yet early observations from telescopes like Hubble showed mostly a teardrop-shaped coma of dust, without a significant tail trailing behind it. For Loeb, this was another red flag. He posits that if this were an alien probe, it might not outgas like a normal comet. He even suggested that the glow around it could be a cloud of small particles released intentionally to act as a buffer, protecting the spacecraft from collisions as it travels through our asteroid belt. This theory paints a picture of a technological artifact, not a natural comet, intelligently navigating our solar system. Of course, the mainstream scientific community has pushed back hard against this idea. NASA scientists have stated that the evidence overwhelmingly points to 3I/ATLAS being a natural, albeit very strange comet. They argue that it looks like a comet and does comet things. As it has gotten closer to the Sun, it has indeed started to grow a more significant tail, which seems to support the natural origin theory. They explain the weird composition and behavior as simply a sign of the diversity of other solar systems, a chance for us to learn that not all comets are made the same way. For them, 3I/ATLAS is a scientific wonder, not an alien spaceship. But the questions raised by Loeb and others linger, tapping into that deep, primal curiosity about our place in the cosmos. Is it just a rock, or could it be something more? The final verdict hinges on what happens as it gets even closer. A cosmic question mark. So here we are, faced with an object that defies easy categorization. On one hand, we have the steady, methodical voice of mainstream science, telling us that 3I/ATLAS is a natural comet, a bizarre and ancient one, but a comet nonetheless. The shocking data from the James Webb Space Telescope, the unusual composition, the early activity, all of it, they say, is just a lesson in cosmic diversity. It's worse than predicted only because our predictions were too narrow, too based on the limited sample size of our own solar system. It's a chance to expand our understanding, to rewrite the textbooks. In this view, 3I/ATLAS is a gift, a challenging puzzle from the cosmos that will ultimately make our science stronger. The growing tail and predictable cometary behavior seem to add weight to this safe, rational conclusion. But then, there's that other voice, the one that speaks to the average Joe in all of us, the part that looks up at the night sky and wonders, what if? This is the voice that asks the uncomfortable questions. Is it really just a coincidence that this object's trajectory is so perfectly aligned for planetary flybys? Is its bizarre chemistry really just a quirk of its formation? Or could it be the exhaust or byproduct of something artificial? The thing is, when something is so far outside our normal experience, it's natural to wonder if we're missing a key detail. Are we so committed to finding a natural explanation that we're ignoring evidence that points to something truly revolutionary? Many people are crazy about definitive answers, but the universe rarely provides them. What if the truth is somewhere in between? Or what if both sides are wrong? The thing nobody tells you is that science is a process of elimination, and we simply haven't had enough time or data to eliminate all the possibilities for 3I/ATLAS. We are witnessing this object's journey through our solar system in real time. Every new observation, every new data point adds another piece to the puzzle. We are like ancient astronomers trying to understand a solar eclipse for the first time, armed with powerful tools but a limited framework for understanding what we are seeing. This is the heart of the mystery. Did all this happen overnight? Of course not. This object has been traveling for billions of years, but our awareness of it, our frantic race to understand it, is happening in a blink of an eye. The debate between a natural comet and an alien probe highlights a fundamental tension in science and in human nature, the conflict between the known and the unknown, between caution and imagination. As 3I/ATLAS continues its journey, speeding toward its closest approach to the sun before it slingshots back out into the void forever, we are left to wonder, will it reveal its secrets? Will it erupt in a brilliant display of outgassing that proves its cometary nature beyond all doubt? Or will it do something else, something unexpected that deepens the mystery even further? We are all viewers watching this grand cosmic drama unfold, and the final act is yet to be written. As 3I/ATLAS heads back to the stars, we're left with more questions than answers. Do you think we're seeing a natural wonder or something more? Let us know in the comments, and don't forget to like and subscribe for more cosmic mysteries.